All right, hello everyone. We're doing 2.4 day 1, learning some new factoring strategies. All right, a real quick factoring review. You do always want to look for a common monomial to pull out front first. And after you do that, ask yourself if it's old-fashioned method or box method, or maybe even a special case. So let's review all those methods. Do you remember what I call old-fashioned method? No one? If I have x squared plus 6x plus 8, it's just like the most general factoring method that we've used this year. It's the one where you brainstorm ways to add up to 6 that multiply together to get 8. So can you think of those numbers? 4 and 2. Yeah. So it's just, I call it old-fashioned because it's just like our old favorite method we've been doing since the beginning of our factoring journey together. All right, the box method, those are harder to come up out of my head, so I'm not going to actually come up with one, but it'd be like 4x squared plus 7x plus 10. It's when you have this leading coefficient, then you have to draw your box and do it with that method. Or guess and check if you hate the box method, of course, but still works. And then the special case I want to review with you guys is when you have x squared minus 16. This is a special case because both of those terms are perfect squares. Do you remember how to do these? It's on the chapter 1 test. Yeah?
Can you do like 3x minus 4 and 3x plus 4?
Good. 3x minus 4 and 3x plus 4. What Ethan did is he ended up square rooting both of these terms because they are both perfect squares. And he has 1 plus and he has 1 minus, and that's essential so that the inners and outers, if I would refoil this, would add up to 0. And do you remember how those work? Nod your head if you remember how this works. Okay, very good. All right, so our job is to look for a common monomial, pull it out front, and then see if it can be factored any further after you do that with any method. Pull out a common monomial. What's that, Nick? Do you know what a common monomial is? Okay, what do they have in common? What do all three terms have in common? An x, yep. We're going to pull that x out front, and we're going to see what we're left with after removing the x. How about I'm going to volunteer tell me. Kylie?
So the first one's going to be x squared.
Okay.
And then 2x.
Good.
And then minus 1.
Good. All right, so what we're left with here is a trinomial. And we are going to do the old-fashioned method. So we're going to think of ways we can add up to 2 and multiply to negative 15. 15 and 1, 5 and 3. That's about it for options yet.
Would it be 5 plus negative 3?
Good. Positive 5 with a negative 3. Yep. And then you're done. This is called factoring completely. Everything is factored that can't be. All right, here's your next one. You're going to draw it down. All right, when you do this common monomial factoring, you don't just want to pull out one thing they have in common. You want to pull out as much as humanly possible. Every single thing they have in common. So anybody have an idea? Nick?
I think it's 2y to the third.
Yes, good. So not just a 2, not just a y, but 2y to the third. Because that has 5 y's and that has 3 y's. So we can take 3 out front. All right, so when you divide it out, you're kind of subtracting those y's away. So if you had y to the 5th and you take 3 y to the 3rd out, you do 5 minus 3 and there's 2 left inside. Does that make sense? Because these would multiply together, and when you multiply these together, you end up adding their coefficient, or their exponent, sorry. Wrong word. All right, negative 18 divided by 2 is negative 9, and there's no more y's left. So you take all 3 of them and pull them out front. Do you think we're done? You think this is factored completely? There's a catch. Our math teacher's always putting catches in there. perfect squares. These are the difference of perfect squares that we reviewed as that special case. So Ethan was the one that remembered how to do this. Do you remember? You do 1 plus, 1 minus. And then you can use square roots to figure out what's going to go in each group. So we'll have y's right here. But what will our numbers be? One's positive 3, one's negative 3. Now we're done. It's factored completely. All right. Want to try this one by yourself? All right, let's try this by yourself. I'm going to pause the video real quick while you work a little bit. All right, so hopefully you worked on this a little by yourself. Did you pull out a 4z squared? And then what you're left with is old-fashioned method. What numbers add up to -4 that multiply together to give you positive? Both of them are -2s. Yep. So now we're factored completely. How many got that all by yourself from beginning to end? Close. How many of you at least got the common monomial part right? That's better. All right. Okay, moving on. We're going to learn a new special case called sum and difference of perfect cubes. Have you ever even heard the term perfect cube? Oh, good. We've done perfect squares. Perfect squares are all the numbers that have a nice square root to them. All of these numbers would have a nice cube root. In other words, 1 equals 1 times 1 times 1. And 8 equals 2 times 2 times 2. And 27 equals 3 times 3 times 3. So you don't need to memorize the list, but it is helpful if you recognize these numbers when you're doing these factoring problems. And then the next thing we're going to do is look for the cube root button in the calculator. So get ready for that. All right, so let's say you saw the number 125. You were factoring something and you saw 125 and you're like, oh, I think it's a perfect cube, but I can't remember for sure. You can test it by doing the cube root. And to find the cube root button on your calculator, you want to hit the math button, and then you want to hit number 4. So if you forgot where the math button is, it's over here in this left column. It's also where like the fraction button is located. So you would hit math 4, and then you could cube root 125, and it equals 5. And that just means 125 was indeed a perfect cube, since the cube root is a whole number, an integer. Math 4, did everybody find it? So just to practice using the button again, why don't you do 3,375. Figure out if that's a perfect cube for me. So do the cube root. 3,375.
Yes.
Yes, it is a perfect cube. What number is it? 15 cubed equals 3,375. All right, well, here's where we're headed with all this perfect cube stuff. We are doing sum and difference of 2 cubes. So here's the formulas that you will be using to help us factor. You do not need to memorize these. I already have them up on my formula board. But you're definitely going to have to know how they work. So we'll do a couple example problems using the formulas. And then we have a catchphrase. You probably want to write this down too. So same, opposite, always positive. And I'll explain to you what that means. Sing it. I know, I didn't make up a song for this, so. How did that set go?
What?
Sing it again. You might have a good tune and I could use it.
No, no. I was like holding my lip and I couldn't talk right.
I need like a little tune to set it to. If I can have a tune, I can probably sing it.
That's what I was doing.
Same, opposite, always positive. Same, opposite, always positive. It's not really, it's too short to be a song, I guess.
Just remember, so
Just remember soap. So here's what soap actually means. If you're doing the sum of two cubes, do you see how the sign is a plus? You'd put that same plus sign in your binomial. Then in your trinomial, you'd put the opposite symbol, a minus sign, and then you'd always have a positive sign here. So for the difference of two cubes, it's a minus sign. So the same sign, the minus sign, would go in your binomial. And then in your trinomial, you'd put the opposite sign, a plus, and then always a plus for the last one. So you have a binomial and a trinomial when you factor these, which is awkward because we normally factor into binomials. Spencer?
That is a cubed and plus b cubed, right?
Yes, a cubed plus b cubed.
Sorry, it's a little.
You can move up here for today.
No,
She's
it's not. It's not even that.
Okay.
It's just
A little blurry.
the lettering is. Yeah.
The lettering is dim. You have light?
Saturated.
I need a new smart board projector to help.
yeah, that's what we're talking about.
All right, we ready to try one of these? I'm gonna get a new slide to try one. We'll do that first one that was up there. 8x cubed plus 27. So you know 8's a perfect cube, it's on our list. You know 27's a perfect cube, it's on our list. So we're gonna treat this one as the sum of perfect cubes. Before we start though, we need to establish what was cubed to get 8 cubed and what was cubed to get the 27. You guys know? A 3 was cubed to get the 27, so that's going to be our b value. And a 2x was cubed to get the 2x cubed. So those are our a and b values. So what we're going to do is set up ourselves a binomial and a trinomial. In the first one, it has the same symbol as what we had originally had, so it's a plus. In the second one, it has the opposite symbol and then always positive. So that's how I set up my symbol. So that's where your soap comes into play. Same, opposite, always positive. So your first binomial, however you want to say it, would just be 2x plus 3. Because it's a plus b. That one's the easy one. A plus b. Now the second one gets a little bit harder. It's a squared. What is 2x squared? Think of it like this. 2x squared, but squared on the outside of the parentheses. 4x squared. Good. The second term is a times b, 2x times 3. So that would be 6x. And the last one would be b squared. So 9. And you're done. Now, how could you check if you're right? Because you can definitely check these. You cannot type it in, unfortunately. No typing it in. Right, do either your rainbows or your box to foil this out. Yeah, it would foil out and give you 8x cubed plus 27. Do you want to do that for fun? No. It would take some time, so we won't, but it will foil out correctly. How do you check it? Yeah, do you use rainbows or boxes? So I would draw myself a 2x3 box. He doesn't want to do it. I would draw myself a 2x3 box, put my 2x plus 3 here, my 4x squared minus 6x plus 9 here, and it should all foil out correctly. Spencer?
So for the opposite equation, the a cubed minus b cubed equals a minus b.
Mm-hmm.
For that last part, would it be a squared plus ab plus b squared or minus b squared?
Plus b squared. The last one's always positive, and that's why the term soap goes same, opposite, always positive. You know why that is, right? Because even if b is a negative number, if you square it, it would turn into a positive number. All right, let's do one with the minus sign. Here's one with the minus sign. This has the added bonus of having a common monomial that we have to take care of first. Yay! Happy Monday. So is the common monomial 4? Now, what I did is I take that 250 and I experimented a little bit. I tried dividing it by 16 first. That didn't work. I tried dividing it by 8. That didn't work. I tried dividing by 4. That didn't work. So 2 is actually the biggest number you can divide out front. That was surprising to me, actually. So I'm going to pull a 2 out. Are there any z's I can pull out? 2 z's. So on the inside, we have 8z to the third minus 125. Was 125 on our perfect cube list?
Yes.
Yes, it was. And if you forgot, you can always cube root it. And it is 5, yeah. All right, so somewhere off to the side, I'm going to jot down what a and b are. In other words, what values were cubed to get 8z cubed and negative 25, 125. Do you know what they are? 2z and 5. 5 cubed is 125. And now we can set up our binomial and our trinomial. Spencer, here's your minus one for you, since you were asking. So we're going to, you know that phrase, so same means we're going to put the same symbol here as what we started with. So this will be a minus sign. Same. Opposite means put the opposite. And then the last one, oops, is always positive. Figure it out. Off the board. So our first binomial is just a minus b, or 2z minus 5. Our second trinomial here is a squared, so 4z squared. I think that's probably going to be the hardest one to remember, because you have to square the 2 and square the z. And then what is a times b going to give us? And then b squared is 25. And that is how our perfect cubes work. Sum and difference from cubes. We have one more factor strategy to teach you guys. It's factoring by grouping. It's like my favorite. It really is. I'm not even saying that. No, this is my favorite. I mean, I like the box method, but factoring by grouping is my favorite factoring method. And I really like synthetic substitution. So I wasn't lying when I said I loved that. All right, factor by grouping. Let's do this one next. So factor by grouping, go ahead and jot down the term factor by grouping. And jot down that you want to utilize this when you are starting out with 4 terms. Almost everything we've done so far, you've started off with either 2 terms for the special cases, or 3 terms for old-fashioned method and box method. But this is the first time we've factored anything that had 4 terms to begin with. So all you people that like colors, I know Cassie likes colors like I do. Cassie, where's your seat? There you are. You can use colors on this. We're going to make a pink group and a green group. When people get new seats, I can never find them for a long time. You like threw your pencil out like, oh, finish that one, Maurice.
Yeah.
Did you finish it? You know, grouping? Or not?
Oh, yeah.
Okay. So what we're going to do is we're going to create a pink group and we're going to create a green group. And you're going to do common monomial factoring on both groups. So, what common monomial do my pink terms have in common? X squared. Yep. So I'm going to factor on x squared for my pink group, leaving with an x minus 3. Now I'll kind of lead the way with the green group. My green group, what I'm going to factor out is a negative 16. And I know that's probably not what you would have thought of looking at that 48. You probably would have been like, oh, I'm going to factor a negative away from a positive number. But I'll show you why I'm doing that. I'm kind of thinking ahead. So if I factor out a negative 16 from the first term, I'm left with an x. And if I do a 48 divided by negative 16, I'm left with a negative 3. Now I will show you why I selected the negative 16. You see these 2 groups? It is very, very, very important, if you're doing factoring by grouping, that these be the exact same group. If they're not the exact same group, you may not continue on your journey and you have to start over. Okay, so I used a little bit of looking ahead to help me make that decision, pull out that negative 16. Okay? And this is where it gets a little strange. These two, it's kind of like you do abracadabra, kapoof. You basically take these two, and I know that's crazy, you're using magic, right? But you're going to take these two, and they're going to collapse down into a single group of x minus 3. You don't want to make it x minus 3 squared. That's what everybody's thinking today. It's just they're going to be abracadabra and become one single x minus 3 group.
For x minus 3, would you use a certain color or no?
Oh, no. I'm collapsing them down to the same groups. Doesn't even matter what color you use at this point. And then this x squared and this negative 16, they actually create a brand new group. And that's how the factoring by grouping works. Isn't that weird?
That's crazy.
And people are like, how does that even work? How does it even work? You can see how it works really easily with foiling. Isn't x squared times x going to give you that x cubed we started with? And isn't x squared times negative 3 going to give you that negative 3x we started with? And negative 16 times x, the negative 16x, and the negative 16. That's actually not our final answer, but that's proving how we did abracadabra and collapse that down into one single group and proving that that works.
What would happen if like the two groups had different numbers?
You'd have to start over. You wouldn't be able to continue on. Yeah, so it's kind of important to make your decisions in a way that you get the same exact group. All right, so unfortunately we're not done with this one. Do you see this x squared minus 16? That's a perfect square, isn't it? So we can do our sum and difference of perfect squares that we've been doing a lot today. X plus 4, x minus 4. And then we still have x minus 3, of course. That's the final answer. Oh, 3 binomials. Yeah, this is not technically a trinomial. Trinomial. These are the most awkward words to say. All right, we have 2 more problems to do. We're doing good on time. Did you like it? Most people at this point are like, ew, grouping's gross, but I think it'll grow on you as we do more. It's better than what method? Oh, the perfect cubes? Yeah, I don't really like perfect cubes. All right, factor by grouping. There's 4 terms. I know I'm going to be using grouping. Like my pink and my green group. So here's my pink group. Here's my green group. What do you guys think we should pull out of the pink group? A 3m? And that would leave us with a 2n. And if you want to check that, 3m times 2n would give us 6mn. And then it would be a negative 3. Do you have any more of the bathroom passes to put in my little tub?
Yeah.
Put one in. I'm collecting those this week for bonus, so I want to make sure you don't get bonus. Just want the bathroom.
For bonus?
Yeah.
Like points?
Yeah.
Points or percents?
You don't use them. You get points.
You get 2% or 2 points?
I haven't decided yet.
Oh, well, I need.
No, not percent. All right, we're going to now pull out. I'm thinking ahead, and I know that I want this to be a 2n minus 3. This is where Mrs. Harp has to be a fortune teller, look ahead into the future. What could I pull out front of my green group so I know I'm left with 2n minus 3? A negative 2. Very good. Because a negative times a positive 2n would be a negative 4n, and a negative 2 times a negative 3 would be a positive 6. All right, the 3m and the negative 2 that were out front both become their own group, and the 2n minus 3 and the 2n minus 3 become a single group together. And you're done, because there's no perfect squares or anything to deal with. You can FOIL it all out to check.
What's the date today?
16. All right, our last one. I'll help you get started, and then I want to have you try it and see if you can graduate the lesson. Grab graduates. All right, 8x squared, 2xy, 12x, and 3y. I have a little hint there saying rearrange the terms. Why do you think it might be beneficial to rearrange the terms?
So you have the Y's together.
Yeah, so right now, the only two terms that have y's are kind of separated from each other, right? So maybe if we just switch the position of these two, the y's can be close together and be in a group, and the ones with more x's can be in a group together, okay? So I'll arrange it. We'll have this be our green group. We'll have this be our pink group. But see if you can finish it by yourself, okay? We'll pause the video. All right, we're back. We got our final answer here. We had pulled out a 4x from our green group, a y from our pink group, and then our groups matched so we could finish it off. Look good? Okay, so the homework tonight is in the book. I do want to make sure you are showing your work on this book homework. We're having people getting lazy as the year goes on. They're just, I think, copying answers from places and being bad students. So make sure you're showing your work on this. Yeah?
Can you go back a second?
Go back a sec. Yep. There you go.